Go.
All right, guys, so we are now going to be moving into the next topic that we're going to talk about here, and it's called molar volume. Now, if you have your help sheet that you're supposed to have, you'll notice that that is at the top part of your help sheet, okay? Remember, we've only been discussing the left and right-hand side. Very first topic we discussed was taking moles and going to particles, particles to moles. That was the right side of the help sheet. Then we moved into talking about molar mass and then converting from moles to grams, grams to moles. That's the left-hand side of your help sheet. Now we're going to be focusing straight up and down at the top part of your help sheet, which is going to talk about molar volume. Okay, so what is molar volume? It's at STP, it's 1 mole or 6.02 times 10 to the 23rd representative particles of any gas that occupies a volume of 22.4 liters. So in order for it to have that volume of 22.4 liters, it must be at STP, okay, which is standard conditions. So the quantity 22.4 liters is called the molar volume of a gas. The volume of a gas varies with temperature and pressure. Because of these variations, the volume of a gas is usually measured at standard temperature and pressure. Now, what is this standard temperature and pressure, okay? So standard temperature and pressure means, or STP, means a temperature of 0 degrees Celsius and a pressure of 101.3 kPa. That's kilopascals, or considered to be 1 atmosphere of pressure, okay? So typically when they do these reactions, they're going to keep the gases at these standard temperature and pressures just in order to have consistency. Now, when you're calculating the volume at STP, the volume of a gas is equal to, when you're looking for the volume of a gas, moles of the gas times this conversion factor. Okay, so remember, we've been using conversion factors in this entire unit. Okay, this is the conversion factor that we are going to use every time we're dealing with molar volume. Okay, every time we talk about molar volume, that's the conversion factor. Now, will it always be 22.4 liters over 1 mole? No, because if you remember when we were talking about particles, if I were going from moles to particles, the 6.02 to the 23rd power would be on top and 1 mole would be on the bottom. However, if I were starting with particles and going to moles, remember, you flipped that conversion factor. So it ended up being 1 mole over 6.02 times 10 to the 23rd. The same thing applies here with molar volume. If you start out with moles and you're looking for volume, okay, you will use this conversion factor. If you are starting with volume and you're looking for moles, you would flip the conversion factor. Remember, it's what I want over what you got, okay? So what you want over what you got. That's kind of how you look at it. And in this particular problem, we want volume and we've got moles, okay? So let's try this problem. So sulfur dioxide is a gas produced by burning coal. It is an air pollutant and one of the causes of acid rain. Determine the volume in liters of 0.60 moles of sulfur dioxide gas at STP. So in this problem, we start with what we were given. And in the problem, we were given 0.6 moles of sulfur dioxide gas. So I'm going to start my problem out and I'm going to say 0.60 moles of SO2, okay? And then I'm going to use my conversion factor because I'm starting with moles and I'm converting to volume. So we have 22.4 liters over 1 mole. So now in my problem, I'm going to pick up my calculator and I'm going to say 0.6 times 22.4 divided by 1, and that's going to give me an answer of 13.44 liters of SO2 gas. Okay? So 13.44. Now, let's do a couple more problems over here on the board. What if I had a problem, and in that problem it said I had 25.4 liters of carbon dioxide gas, and I wanted to know how many moles of carbon dioxide gas I had. Okay, so in this problem, you always start with what you're given. Okay, so what if I wanted to change that to say 35.2 as my given quantity. Okay, process doesn't change. Now, see how I have liters here? I need liters on the bottom. So when I use that conversion factor on the board, I need to cancel liters out. So I'm going to flip my conversion factor, and I'm now going to take 35.2 times 1 divided by 22.4, and it's going to give me 1.57 moles of CO2 gas. Okay? So, this and this are the two types of problems that we're going to be doing when we talk about molar volume. Okay? This is actually one of the easiest concepts that we talk about. So, following this video, you're going to have some example problems that you're going to work on, and if you have any questions or you need our help at all, please do not hesitate to email and let us know. But this should be a very easy concept for you to understand. All right, I hope you have a good day, and I'll see you in our next lesson.